Hi there, I'm Sujata, founder of Grace USMLE Tutoring. I partnered with Achievable to create a comprehensive USMLE Step 1 course for medical students. It combines my years of USMLE tutoring experience with Achievable's powerful software. To learn more and gain access to a free trial, visit achievable.me.
Hello everyone, I'm Sujata. In today's video, I would like to talk about calcium homeostasis. Calcium balance is influenced by intestinal absorption, dietary intake, renal excretion, and bone remodeling. Parathyroid hormone, calcitonin, and vitamin D are the major hormones involved in calcium metabolism. Serum calcium, which is in the ionized form, is the metabolically active form of calcium in the body, and its levels are tightly regulated in the bloodstream. Parathyroid hormone is produced by the parathyroid gland. The cell membrane of the parathyroid gland has a calcium sensing receptor, which is a G protein couple receptor. When the plasma calcium increases, it binds to the calcium sensing receptor, which then increases the intracellular calcium level in the parathyroid gland, which in turn inhibits the release of parathyroid hormone or PTH. When the plasma calcium decreases, there is decreased calcium binding to the calcium sensing receptor, which in turn increases or stimulates the release of PTH from the parathyroid gland. Hypermagnesemia inhibits the secretion of PTH, while hypomagnesemia stimulates the secretion of PTH. Only in severe cases of hypomagnesemia will the PTH release be inhibited. PTH receptors are present in the proximal and distal convoluted tubules of the kidney as well as the osteoblast. In the convoluted tubules of the kidney, PTH actively increases the reabsorption of calcium, whereas in the proximal convoluted tubule, PTH stimulates the activity of the enzyme 1-alpha hydroxylase, which is important and vital in the synthesis of the active form of vitamin D. PTH inhibits the reabsorption of phosphate in the proximal convoluted tubule by inhibiting the sodium phosphate cotransporter. It also increases the levels of cAMP in the urine. PTH increases the serum calcium by acting directly on the osteoblast and indirectly on the osteoclast. Rank ligand is a member of the tumor necrosis factor cytokine superfamily, and it is a very important transcription factor that is involved in calcium metabolism. PTH increases the production of rank ligand or rank L by the osteoblast. The receptor for rank ligand is known as rank. Rank is present on the surface of osteoclast. The binding of rank ligand to rank stimulates the osteoclast, which then increases the resorption of bone. The activity of rank ligand is blocked by osteoprotegerin or OPG. Calcitonin is produced by parafollicular or C cells of the thyroid gland. The effects of calcitonin on calcium metabolism are opposite to that of PTH in that it decreases the serum calcium level by inhibiting the osteoclast and inhibiting resorption of bone. It does so by interfering with cytoskeletal structures that are involved with osteoclast adhesion like actin and integrin, and also by inhibiting rank ligand. Vitamin D is not only involved in calcium metabolism, but it is also an important metabolic hormone. It directly and indirectly affects growth and differentiation of cells. It promotes mineralization of bone, formation of new bone or osteoid. Vitamin D3 is also called as cholecalciferol, and it is synthesized in the skin after exposure to sunlight from 7-dehydrocholesterol. The plant version of vitamin D is called as vitamin D2 or ergocholecalciferol. The active form of vitamin D is 1,25-dihydroxycholecalciferol, also known as 1,25-dihydroxyvitamin D or calcitriol. It is produced by two hydroxylation steps at carbon 1 and carbon 25. The first step occurs in the liver, where carbon 25 is hydroxylated. This is followed by hydroxylation at carbon 1 that happens in the kidney. Hydroxylation of vitamin D in the kidney is done by the enzyme 1-alpha hydroxylase, which is stimulated by PTH. The active form of vitamin D binds to the vitamin D receptor, which then mediates the transcription of genes involved in vitamin D metabolism in the nucleus. Vitamin D induces the expression of a calcium channel in the apical membrane of the enterocytes, which is involved in absorption of calcium from food sources. It also induces the expression of a calcium binding protein called calbinding and calcium ATPase. Calbinding facilitates the translocation of calcium through the enterocytes and prevents calcium toxicity, while calcium ATPase helps in translocating the calcium across the basolateral membrane of the enterocytes into the bloodstream. Vitamin D also increases the absorption of phosphate and magnesium in the intestine and the absorption of calcium and phosphate in the renal tubules. Let's summarize the effects of hormones on the levels of calcium and phosphate. Vitamin D increases the serum levels of both calcium and phosphate. PTH increases the level of calcium while it decreases the level of phosphate. On the other hand, calcitonin decreases the levels of both calcium and phosphate. Hope this video helped you understand some concepts on calcium homeostasis. I'll be soon coming up with a video on disorders of calcium metabolism next. Thanks for watching.